Hello, this is Mrs. Ringrose, and we are going to be talking about graphing some systems today. So I'm not going to have you fill in the vocabulary for a third time, but I did want to review what it is we're doing and where we're going. So after this lesson, you should be able to do the whole thing in order to solve a system. You're going to be able to create equations from a word problem. You're going to be able to graph the equations, and then you're going to use your graph to find the solution to the system. So don't forget what we're talking about is systems of equations, and basically for us we're going to talk about two linear equations but a system could be more than two equations. The point of intersection. This is what we're looking for. That's where the solution is. So if you have two lines that cross each other, the answer we're looking for is right here. All right. And then I gave you the steps, and we're going to fill in the steps again because I want you to be able to recall them very quickly. Number one is put equations into a form you can graph. So usually this means y equals mx plus b. Not always, but usually. If you're really good at graphing using standard form and the intercepts are whole numbers, then you can go with that method also. Step 2, graph lines on the same plane. You graph them on the same plane so you can see where they cross. Step 3, speaking of crossing, find the point of intersection. This is your answer. That's the whole reason why you're graphing. And step 4 is to, of course, always check your answer to make sure it's right. So hopefully I can model all that for you. All right, so example number 1. We have 2x minus y equals negative 5 and 2x plus y equals 1, and our job is to graph those. So if I try to use intercept method, I'm going to get a decimal for x, and so that might not be the best method to graph. So step 1 is to put into y equals mx plus b. So the first one, what I'm going to do, and we could change this work to down here actually. So I have 2x minus y equals negative 5. So the first job is to move the x. So I'm going to do this by subtracting 2x from both sides. Right, because I want that to cancel and get it over to the other side. So 2x minus 2x crosses out, and I'm left with negative y equals, and if it's okay with you, I'm going to just switch these positions to get it more into an mx plus b look. All right, so this isn't what y equals, though. This is what negative y equals. So if you remember, this looks like a negative 1. So I'm going to get rid of that by dividing everything by negative 1. So usually step 1 is to move the x, usually, not always, and step 2 is divide, again, usually. Sometimes you only have to do one of the steps. And then those cross out, so my final equation is y equals positive 2 over 1x plus 5, because this negative negatives, they all change. Okay, great. So I'm going to scroll back up, and our equation is 2x plus 5. So this changed. Y equals 2 over 1x plus 5. And I know that this is my m, and this is my b. So I'm going to start on 5. And then I'm going to move up 2 over 1. Up 2 over 1. And again, I don't know where my intersection lies, so I'm going to go and start going backwards. So down 2 backwards 1, down 2 backwards 1, down 2 backwards 1, all the way until I can't go anymore. Then I'm going to take my ruler and make a very straight line to help me get a good answer later. All right, the next one I'm going to do over here if that's okay, because this one's actually only one step. So what I need to do is get the x moved to the other side to make it look like y equals mx plus b. So if I minus 2 x's from both sides, these cancel, and I'm left with y equals negative 2x. And on this one, the 1 is positive. So remember, I cannot combine the 1 and the negative 2x because they're not like terms. And now I'm ready to graph this line. My slope on this one is down 2 over 1 because it's a negative slope, and I start on 1. So down 2 over 1, down 2 over 1. With this line, I am going to stop short because I know the farther I go down, I'm going to get away from the blue line. So now I'm going to go backwards. So up to backwards 1, up to backwards 1. And I can see where my lines cross. So I'm going to go ahead and put in my second line. Sorry, yours is going to be much better. Sometimes my calibration is off. And where's my answer? Oh, so actually let me do my check marks. So step 1 we did. Step 2 was to graph it, which I did. Step 3 is find the solution. And the solution is where they cross. So that's my solution right there. And that number, or that point, that ordered pair, is negative 1, comma 3. Right? Because my x and y coordinates. Okay, now your job is to prove that that is the right answer. And I'm going to, really rely on a calculator. We've been doing this for a while. What you want to make sure you do to avoid any mistakes is to go back and use the original equations, because if your mistake was where you changed the equation, then that's going to give you, it's going to say your answer's right even if it's wrong. Okay, so the first one is 2 times negative 1 minus 3 equal negative 5. And if I just plug this whole part in the calculator, 2 times negative 1 minus 5, I'm going to get negative 5. And negative 5 equals negative 5. So that one's a solution. Next one does 2 times negative 1 plus 3 equal 1. And again, if I put all that in the calculator, I get negative 2 plus 3, and that does 1 equals 1. So I've proved that my answer that I got is my solution. All right, next problem. This is going to take us a little longer because I want to go ahead and do a whole word problem with you on a video note, and I hope that this goes well for you. So this is again the whole reason why we have systems and equations, is to be able to solve problems. Basically, I'm trying to find the best after-school job. And I kid you not, I did the same thing with my husband when he was looking for a job, and he had 2 options. And I made a system, and then I solved it, and we decided, well, if you're going to do this many hours, and that many, so, it definitely is something that you can use in real life. So you're looking for an after-school job. One pays $9 per hour. All right. So that sounds like an M, because it's a rate of change. Another pays $12 an hour. So that sounds like an M. All right. But you must pay for a uniform that costs $21. So is that $21 that I'm given, or is that $21 that I'm going to lose? That's $21 that I'm going to lose. So it sounds like I have a beginning cost of negative 21 because I'm going to lose it. So the point is, after how many hours will the jobs be the same? Because I'm not starting at $0 if I have to pay out $21. I'm starting, in debt. So step 1, we're going to say, is make the equations on this one. Right. So it sounds like it's dollars per hour, right? Or is my rate of change? So y is going to be my dollars, and X is going to be my hours, defining my variables. So job number 1, it looks like I make $9 per hour. And there's no beginning. I just walk in, I'm at $0. And then job 2, I make $12 per hour, but again, I'm negative 21 when I started. So that's my system. Step 2 is to graph. All right, this one's going to be very challenging to graph because of the numbers involved. So I kind of left this grid blank so we can kind of think about it together. The second equation starts negative. Okay, so as I was saying, this is a little challenging because of the numbers involved. So, there's different ways to scale it. I tried to scale it with putting the negative 21 on there, but that made it a little challenging. So we're going to do this one a little bit differently, which is why I wanted to do it with you. So this is how I decided to scale it after actually putting a lot of thought into it. Again, our x-axis is the number of hours, so you're going to want to make sure you label that. And my y-axis is the number of dollars that you earned. So the first equation is pretty easy to graph on here. My y-intercept is 0, so I'm going to start here. And then every hour that I go across, I've earned $9. So again, my m on this one is up 9 over 1. So that doesn't mean up 9 boxes because I decide to scale each box by 3. So I have to really be careful and count. So I want to make sure I go up to 9 and then over to 1. So don't worry about the boxes so much. Worry about the scale of it. So I went up 9 and over 1 hour. Up 9 and over 1 hour. Up 9 and over 1 hour. Up 9 over an hour. Up 9 over an hour. Up 9 over an hour. So this is what y equals 9x looks like. All right. So as I said, I couldn't get negative 21 on my graph, but that's okay. We have other ways to graph, right? I could make a table. Tables are awesome. So what a table looks like, and this is just for the second equation, is, and you can make a table for the first one too, that's fine, is I'm going to put 1 hour in here, and I do 12 times 1 minus 21, and I get a negative number, right? I get negative 11. No, that's not right. Negative 9. Haha, just kidding. So that's still negative, so I can't graph that yet. If I put 2 in here, I do 12 times 2, which is 24, and then minus 21, which is 3. So this is something I can graph. So over 2 hours, up 3 hours. All right, now I can still keep going. If I put 3 in there, 12 times 3 is 36, minus 21 is 15. So over to 3 hours, and then up to 15 on my graph. And from here, I can start using my slope if I want. I know that each one's going to jump up by 4 because that's the slope of my, not by 4, it's going to jump up by 12 because that's the slope in my equation. Okay, right? So over 4, up 27, over 5, up to 39. See how my black line is getting closer? Over 6, really, really close. And then over 7, and it's actually off of the graph, which is okay. I kind of intended that to happen. So I really want to make sure that I'm really mindful about how I make my graph. So it looks like it's right there. So we have to kind of make a guess, right, as to what this point is. So it looks like I'm at 7 hours. And if I'm at 7 hours, I'm just one more box up. So I'm at $63. That's where these two lines cross. And then what you can do is step 4 and plug them both in the equations to see if it works. Thank you.